Welcome to yet another class. I'm Dr. B, your chemistry teacher, and today we are going to be looking at coordination compounds and nomenclature. Quite a very wide area in chemistry, and this area is bound to inorganic chemistry. Quite an interesting area, but very wide. We are going to introduce ourselves to how we can name these complexes, how we can name coordination compounds. To name coordination compounds is quite dicey, but it's important that you know how to name them, following their rules. And that is our interest in today's class. Don't forget to share this class. And when you share this class, don't forget to tell those you are sharing this class with in your groups to do what? To subscribe to the YouTube channel, and then they will be able to get these classes as they come. Do not also forget that I have a Facebook page, Dr. B Chemistry Classes, and just tell them to go there, watch, share, and let them follow as well, and like and comment. Send in your questions in form of comments, and they will be attended to. Thank you. Now, what are coordination compounds? What are coordination compounds? Now, there is a very simple way to define them, and I'm going to let us know that coordination compounds are simply chemical compounds that are simply bonded. Okay, they are compounds that are simply having central metal atoms, and then they also have ligands that link to the central metal atom bonded by coordinate covalent bonds. That is just a simple way of understanding what coordination compounds are. They are chemical compounds. Okay, they are chemical compounds, and these chemical compounds are simply having an arrangement or an array of anions and neutral molecules that are bonded by a central metal atom, and then this bonding is by way of what? By way of a coordinate covalent bond. So that is the only way you can understand what coordination compounds are. Once more, let me just explain again. Coordination compounds are simply chemical compounds that have an arrangement of anions or even neutral atoms, bonded to a central atom, linked by what? Linked by simply a coordinate covalent bond. That means that if these compounds are not being linked by coordinate covalent bonds, then they are not coordination compounds. Again, it also means that if they do not possess a central atom that hooks to either anion or neutral atoms as ligands, then they are also not what? They are also not coordination compounds. Now, these coordination compounds are simply identified with the help of the presence of a central atom. But it's important for us to know that coordination compounds are also called coordination complexes. Okay, so either you call them coordination compounds or you call them coordination complexes. Do you know that these coordination complexes or compounds that possess a central atom are always hooked up to anion or hook up to a neutral atom, and these neutral atoms or anions that hook up to these central atoms are called ligands? And these ligands can also be called complexing agents. So if you do not want to call them ligands, you can also call them complexing agents. They are always what is bonded by coordinate covalent bonding to the central atom, and that is what form what you call a complex, either a coordination complex or coordination compound. Quite interesting. Now, let me also surprise you to know that these particular coordination compounds could have the central atom a metal. And if it has a central atom as a metal, then it can also be described as metallic complex. That means you can call it coordination compounds or coordination complex or even metallic complexes based on the fact that they possess a metal as their central atom. Do you know that the metal that these coordination compounds always has as their central atom are usually transition metals? That is why in our class that we have discussed transition metal, we told ourselves that transition metal have certain characteristics, and one of the characteristics is the formation of complexes. That transition metal form complexes. They also form color compounds because of the DD transition, which is as a result of the half-filled or incompletely filled orbitals. So the transition metal will always be that particular metal that gives this name, gives this compound that name, metallic complexes. If they are transition metals, then it means that the entire complex can also be described as a metallic complex. All right. Now, if we take that to be true, then it means that we can say that a complex, a coordination compound or a coordination complex or a metallic complex simply is made up of a central atom, which can be a metal, a transition metal, and then it's also made up of what? Of ligands that can be anions or even neutral atoms bonded to them, bonded to a central atom by the help of a coordinate covalent bond. Alright, that is the nature of the coordination compounds. Now, it's important for us to know that coordination compounds usually have a property that is unique, and that property is that they have an incomplete ionization. They have an incomplete ionization property. Okay, so they can ionize to give you either they give you the metal itself, they give a metal and a complex. So if you have, for example, this kind of a compound that you have here as a coordination compound, this is simply this is simply potassium, okay, potassium cyanide ferrate 2 ion. Now, if this compound happens to ionize, it will give you the potassium component, and it gives you this. It gives you this. Okay, so this is potassium, while this is simply the hexacyanoferrate 2 ion. Of course, this is the incomplete ionized compound. Okay, the incomplete ionized complex, as the case may be. So this is a very unique property of the coordination compounds, that usually they form incomplete ionizable products at the end of the day. Now, that's being taken, it's important for us to know that there are different types of coordination compounds or coordination complexes or metal complex, the case may be. Okay, so if you look at the different types of these complexes, we have a cationic complex. Okay, we have a cationic complex. Now, these different type of coordination compounds are defined by the help of their coordination sphere. And what is a coordination sphere? The coordination sphere simply explains a complex, explain the non-ionizable component of a complex that consists of the central metal atom and also consists of the ligands. So inside a square bracket. So it means that once you see this inside the square bracket has a central metal and has the ligand to it. So this is the incomplete ionizable part of the complex. So this incomplete ionizable part of the complex is what defines the coordination sphere. And if this coordination sphere is made up of a cation, then we define this complex as a cationic complex. And this is a good example of a cationic complex. So a cationic complex simply possesses a coordination sphere that is made up of a cation. And like I said, the coordination sphere is simply the central metal and its ligand inside a square bracket. That is the unionizable part of that particular coordination compound. So we also have an anionic complex, which is also another type of coordination compound. And this anionic complex is simply explain that particular coordination compound or complex that possesses an anion as its coordination sphere. And good example of such um, complex, which is anionic complex, is this. We also have another complex that is a neutral complex. Okay, it's a neutral complex. So we also have neutral complexes as coordination compounds or coordinate complexes, and these neutral complexes do not possess either an anion or a cation, as the case may be. They are neutral complexes. For example, complexes that possess ligands that are maybe amines, or that are carbonyls, or that are even aqua. Okay, all these ones are neutral complexes. They don't possess coordination spheres that are anions or cations, as the case may be. Right. So those are neutral. Those are always seen as what, as neutral complexes, as the case may be. And then you also have a homo. You have a homoleptic complex and a heteroleptic complex. So you have a cationic complex, anionic complex, neutral complex, homoleptic complex, and heteroleptic complex. Now, the homoleptic complex are simply complexes whose coordination pairs are not bonded to whether they are cation or anions, as the case may be, but they have coordination pairs whose ligands are the same. So if these ligands are the same in that particular complex, it is described as a homoleptic complex. For example, a complex like this or this has a single ligand, so we said it has an identical ligand. So because it has an identical ligand like for this or this, you can describe it as a homoleptic complex. But where the ligands has different ligands, that means it has more than one ligand, so there are different ligands in that complex, you describe such complex as a heteroleptic complex. And the good example is like this complex you have here. So you can see that there's a ligand here, there's a ligand here. Okay, now this ligand is different, this is different, this is. So there are three different types of ligands in this compound. In this kind of a compound, you describe it under heteroleptic type of coordination compound. So there are different type of, so let's say this is, okay, so we can simply still describe this as this. We can simply still describe this as homoleptic complex with a single or an identical ligand. So these are the different types of ligands, okay, the different types of coordination compounds or complexes that we have. All right, so how do we name complexes? How do we name complexes becomes the bone of contention. We are going to use these 5 examples to treat how we can name complex, and if you pay attention to what we are going to be doing here, you are going to find it quite easier for you to name other coordination compounds or complexes or metallic complexes, as the case may be. Now, there are rules that govern the naming of complexes. You don't just wake up one day and start naming complexes. There are rules that govern the naming of complexes, and we're going to see few of those rules that govern these complexes. And when we understand the rules that govern the naming or the nomenclature of complexes, then we will be able to understand how we can name the rest of the complexes. Now, to name complexes, these rules apply. To name complexes, these rules apply. Now, the first rule to understand is that if you must name complex, you must know that the naming of complex begin with the ligand. Take note of that. The naming of a complex begins with the ligand. And it means that if we want to name these complexes, we must begin naming these complexes with the ligands first. These are the ligands that are attached to the central metal, to the central ion, okay? To the central metal ion. Okay, like this, an iron cobalt. So these are central metal ions and these are ligands. So in order to name a ligand, so to name a complex compound, you must first start from naming the ligand. I hope you have written that down. That is number one. You must start from naming what? The ligand. Now the second thing you must understand that after you name the ligand, then you can now name what? The central metal ion or the central atom. So once you name the ligand, the next thing expected for you to name is the central ion. Now, if there are various ligands like we have here, you have to consider the ligands before you come to the central atom. So once you name the ligands, the next step is to name the central metal ion. Okay. Now, if you have named the central metal ion, the third thing you must understand is that you will need to understand what oxidation state is the central metal ion. You cannot name the central metal ion without knowing their oxidation state, to which they are in this complex. So the first thing I said is you first begin by naming the ligand. The second thing is you name the central metal ion. The third thing is you must know the oxidation state of the central metal ion that it is in these complexes, because you will need it. The third thing is if you have ligands more than just one, you are going to name them alphabetically. Very important. If you have ligands more than one, for example, like where you have these ligands here, two, where you have these ligands here, you have to name them alphabetically, because the convention is that if there are more than one ligands, alphabetical placement of the ligands must be considered. That is another one. Now, another rule you must understand is that you must name this particular number of molecules of the ligands. Either you name them in terms of bis, in terms of tris, or you name them as di, or you name them as tri or tetra. So you have to know that you must name this number of molecules of these ligands that are here as either bis, tris, di, tri, tetra, as the case may be. Another rule you must understand in naming coordinate compounds is that if you are naming coordinate compounds, there are some that are neutral compounds. And apart from neutral compounds, you have to replace every letter E in the ligand with O. Very important. That is to say, we have neutral ligands. Example of neutral ligands are water, okay, ammonia, carbon monoxide, nitrogen oxide. These are neutral ligands. These neutral ligands are named just the way they are. But apart from neutral ligands, you are going to name the other ligands by replacing E with O. For example, if you are having sulfate, if you are naming sulfate in this coordination compound, then this will be replaced with O. So you rather name it as sulfate 2. That's what it means. If you are naming chloride, then this E have to be replaced. So you rather have chlorido. See? The same thing. Okay? So if you are naming cyanide, for example, so you are going to replace the E with cyanide. So that is the normal convention. So apart from this neutral ligand, 1, 2, 3, 4 neutral ligands, every other ligand that you are naming in coordination compounds must have their final E replaced with O. That is very important that you have to know. And now, for these neutral ligands, this is known as aqua. Okay? That is water as aqua. And this is named as amine. And this is named as carbonyl. And this is named as nitrosyl. You see, so These are constant nomenclature that you must know. That the neutral molecules, the neutral ligands 1, 2, 3, 4 are named the way they are: aqua, amine, carbonyl, and nitrosyl. Apart from that, every other ligand that is being used in a coordination compound or complex is named by replacing the E with O. Like I say, sulfate is sulfato, and then chloride is chlorido, cyanide is cyanido, and all those kind of things. Now, having understood the rules that govern the naming of coordination compounds, can we attempt to name these coordination compounds that we have here? Now let us see. Alright. Now, this coordination compound that we have here, how do we name it? Following our nomenclature, can you try? Now let us see if you are correct. Now, we start by naming the ligand. We said that before. After the ligand, we must understand that there is the number of moles of the ligands here that we consider as either tri, di, tetra, hepta, penta, hexa, and all those things. And then we come toward the metal, the central metal, okay, or the central atom, and then all those kind of things. So if we have to name that, that means this is what? This is hexa, the 6. Am I right? Hexa. So this is hexa. This is ammonia, and this ammonia is a neutral atom. From what we discussed, as neutral atom, you are or ligand, you are going to name it with the right convention, amine. So this is hexa, amine, cobalt 3 chloride. Cobalt 3 because in this complex, cobalt has an oxidation state of 3. So we will say this is what? This is hexa amine cobalt 3 chloride. That is it. That is it. I'm sure you got it right. Never mind. From now you're going to get it right. So we have hexa amine cobalt 3. Okay, so this will have been like probably plus 3 cobalt 3 what? Chloride. Now that is it. You can see that we named the amine before the chloride because if there are more than two, there's more than one ligand, you have to apply the alphabetical order. Do you see that understanding the rules that I have highlighted just about now concerning nomenclature of complexes will help you to be able to name your complexes. Now let us look at the second one. The second one is what? Now in this second one, we are going to consider first the potassium metal that is outside the bracket, because remember that this is where we talk about the unionizable characteristics of the complex. So here we are going to name this. So by naming this, it means that we will have potassium hexa cyanide hexa okay, and then we have iron. So this is ferret, okay, 2 iron. Okay, see, so this is potassium hexacyanoferrate 2 iron. That means the oxidation state of iron in this particular complex is what? Plus 2. Okay, it is a cationic complex because it has a sphere that is what? A sphere that is plus 2. Now this is another compound. From the convention we have already, how do we name this? This is simply tetracyanonickelate 2 iron. Simple. So you have this as tetra, tetra, and this is what? Cyanide, nickelate, 2 ion. Okay, so you have tetra cyanonickelate 2 ion. Now how about this? Now to name this, we have, this is hepta, that is 5. Okay, this is hepta. So we have hepta-amine, hepta-amine, being that amine is a neutral ligand, hepta-amine sulfate 2, sulfate cobalt, what? Cobalt 3 chloride. Okay, so you can see. So this is simply penta. Oh, sorry. It's penta, no hepta. Penta. Okay, so you have penta, that is 5. Penta, amine, sulfate, cobalt 3 chloride. So simple. Although once you understand what we had put forth as the rules, to be easier for you to name coordination compounds. Now, can you on your own name this? Take this as your assignment. Try to name this coordination compound and place it at the comment section. Let's see who is correct. Assignment. Name this coordination compound and place your answer in the comment section, and we will see who is correct. Until next time, do not forget to share, do not forget to like, do not also forget to comment. Please send this answer to the comment section.